What's the one thing that you can't live without? Guess what? It's backups. And what do backups need? They need a shit ton of space. Enter Cohesity. Today, we're going to be walking you through a super quick intro to Cohesity and how to get this cluster set up. So Cohesity is a complete one-stop data management platform. It can back up and protect almost any technology, including VMware, Hyper-V, Nutanix, physical servers, SQL, MongoDB, Office 365, Azure, AWS, and plenty more. It's got some pretty cool features like immutable backup, global file search, long-term archiving, and proper multi-tenancy support, which is something that we'll be taking complete advantage of. We'll be consolidating our backup technology and enabling new features for our customers and partners. We've opted for a 4-node configuration, so that's 4 of these, which should give us well over 200 terabytes of usable space. So these nodes are the C6025s, which have 96 terabytes of onboard storage with 6.4 terabytes of PCIe flash. And now, let's get this unboxed. So here it is. This is one of the 4 nodes. As you can see, it's got 10 gig ports on the back, dual power supplies. Inside is 128 gig of RAM and 2 Xeon Gold processors. Now this one, Helios, which is the Cohesity OS. This node will become a component of the cluster, and they'll all join together to share resources and provide us with distributed storage. Let's get this and the 3 other nodes into the data center, and we'll pick this back up to walk through the configuration. Cue the data center montage. We're cheating. I had to configure the nodes in the office because they use multicast, and I don't think Cohesity really thought about it when they designed them, because I think they're pretty much designed for deploying in an enterprise, not necessarily in a data center multi-tenant environment. Long story short, you had to be physically plugged into them to configure them. So what you need to do is basically get all your 4 nodes, or basically minimum 3 nodes configured, get them online, plug them into the same access VLAN through their sort of 10 gig NICs, plug your IPMI ports into the same VLAN, and then you can basically log in and start the configuration process. There probably is a way to get multicast working, but for getting this done quickly and easily, and probably what you would just do anyway, is just plug straight into them and go through the configuration wizard. So we've effectively cross-patched a cable which goes from this floor port to the other room so that we can have all the servers running without all the noise. And then we're going to walk through the cluster setup wizard so you know exactly how to build your Cohesity cluster. First things first, every single chassis. So we've gone with the nodes where it's not just one physical appliance that has 4 nodes in it, it's 4 separate physical servers. So there are effectively 4 chassis that we have got. Each one's got its individual serial number. So we've got them all online, powered them up. They've been booted for like 20 minutes, half an hour. We've plugged in one 10 gig NIC from each one. We've plugged in the IPMI, and now we're going to walk through the setup wizard. First thing we're going to do is we're going to log into the URL. So basically you'll plug in and you'll see here, basically you get a 169 PIPA address. That's normal. That's all you need. It uses multicast to discover its brothers and sisters. And then you can just connect to the host name, which is here. So the host name is chassis hyphen, then the chassis serial number, followed by -node-1.local. And when you browse to that, it actually goes and discovers anything else inside the same subnet, and it will get to the sort of like initial cluster setup wizard. So you'll land at this page and you can just begin the configuration process. So we click on get started. One thing I like to do, which makes life a lot easier, is I like to pre-allocate all my IP addresses before I even start doing the work. So on this Mac here, I've got all our management IPs, the out-of-band IPs, the credentials we're going to use, and the last 4 digits of all the serial numbers, because I want to make sure that when I configure them, I name them like what node number they're going to be in the stack. So first things first, we're at this screen here where you can basically select the number of nodes you want to create a cluster with, which of course we're just going to select all of them, including the one that we're currently plugged directly into. We've effectively got in the back of the node, we've got a USB port. Into that is a USB adapter to Ethernet. That goes into a Cat5 outlet. That Cat5 outlet ends up here into this device. And that's how we're currently configuring it, which is a little bit unusual, to be honest, for like more sort of enterprise tech, but it does work fine from what we've seen so far. Next step, select nodes, and we need to set IP addresses and IPMI IP addresses. So I'm just going to fly through this now, which will speed up for your benefit. Now, this is going to be a bit confusing because the nodes don't correlate with the actual nodes that we've got, which means the IP addresses are all going to be skewed. So I'm just going to quickly append the last 4 digits to my specification sheet so that I know what's what. First things first, chassis serial number ending 008C. So enter the IP address for node 2, and then the IPMI IP address, which for node 2. Next one ending 1E is going to be our node 4. 001E, that is 10104. So now next one, then we've got one more after this. So this is an NW2F, which is node 3. Yeah, I think they need to add so that you can change the config here and actually drag these around so that you can reorder them. That would be much better. So we've assigned now valid IPs for the nodes. But interesting, it hasn't asked for the subnet. So what we'll do is click continue. So now we need to set the cluster name. We have a naming convention that we follow, which, believe me, we spend a lot of time debating cluster naming conventions. So we'd like to use the system it's for, the location, which data center zone that is, and then we put in like the cluster name. I don't know if we necessarily share all of this, but we might share like elements of it. Most people that's going to be .1. Pop in our subnet mask, which is a /24. Pop in our DRAC like out of band gateway. Put in the mask for that, and put in our IPMR username and password. DNS servers, which can use our Active Directory servers. Cool. Now NTP, it's uk.pool.ntp.org. NTP is important with pretty much anything you're setting up. You definitely want to use an NTP server, because then otherwise you end up looking at logs where the times don't sync and it gets really frustrating. Plus it can break stuff like SSL. So next thing now is the FQDN. Now it doesn't actually specify what this is for, but I'm going to take a guess that it reflects the cluster's FQDN. We will set the cluster name, which I'll just copy and paste for ease. I'll put in our subnet there, our subdomain there. VIP address range. We've pre-allocated 4 IPs for our VIPs, which are going to be used. So we're just going to put them inside the same subnet that we've got our sort of management IPs. Let me click add. That puts those in, which gives us the 4 nodes that we've spec for. Now encryption. So encryption, once you turn it on, if you go through the wizard and you don't turn encryption on, you can't turn it on at a later point in time. So the cluster must be built with encryption turned on. Obviously we want data at rest encryption. So we are going to set that encryption key. We will rotate every 90 days, which is reasonable. Click create cluster. Watch the sparks fly. And now we wait. And to wait some more. Okay, so now we've got the build wizard, which is configuring everything. So hopefully this goes to plan. It says 205 seconds remaining. I think we'll come back when it's finished. So it's important to mention this cable is actually plugged into the out-of-band USB management port. So I mean, even if the nodes get re-IP'd, it shouldn't change the IP address of this anyway. Okay, so we managed to get on the cluster web interface. We've been able to get on the IP address, signed in, and we've been prompted for a license key. Now we don't have that license key. We need to log a support ticket to request it. I've checked on all fulfillment emails. We've not got it. I can't actually go and generate it inside the portal. So we're going to open a case. We've rang the technical support team and didn't get through to anyone. So now we're going to log a case and wait for a response with the license key details in. So the guy's going to go to the data center now and actually going to fit it, because we didn't fit it previously because basically we needed to do the config here because of the multicasting stuff. So they're going to go fit that now, and yeah, we can pick this back up once it's in the data center. We'll have remote access, we'll get the license key, and we'll show you some of the initial setup. Cue the data center montage. Okay, so during the last video, we got stuck on the license. So it turns out the version they're on, you actually need to apply a specific key, which they provide to you. The new ones now, when they actually ship on the latest release, you don't need a key. So this only applies if you've got an old version on the hardware that you get. So just going to log in, and I'll get the key pasted in that's been given to us by support. Now we're going to agree to that end user license agreement and get that key entered. There we go. Cool. So we're in. Brilliant. Okay, so next thing we do is going to join the cluster to Helios. So Helios is the actual management plane that's online. So you just go into here, click on enable, and then we'll get a login prompt to actually sign into the support portal. So we'll get signed in here and actually log in, and then this will actually link the unit to my Cohesity page and Helios Cloud. We simply just get signed in, and then it should prompt us to authorize that. There we go, and that's connected to Helios. So now what we can do is you can actually log in. So rather than having to log into the specific IP address of the device, we can actually log into the web interface and actually go and see that now. I'll log in there. Okay, so let's launch Helios, and if we go in here, we should be able to see our cluster, and one that we did a proof of concept with as well, actually. Yeah, so that looks good. So I can see there's 2 clusters joined there, and our new cluster is listed there in the list. And yeah, now we can see everything we've got protected, and we can also administer it. So pretty much most things that you can do on the device, you can do from here and more. And I think it just probably makes more sense to use this on a sort of day-to-day basis. So the first thing we're going to do to get the upgrade done is just going to go and download the file that we need. So we'll go and actually download the latest version of 6.6, and we've actually already got this file sorted and stored, so we're just going to upload that now to the cluster. So just going to go in, select the file, and just grab that file there, upload that, and yeah, that should get the upgrade process started. So that's the Cohesity upgrade finished, pretty painless. I was a little bit disappointed that you couldn't just go in Helios and actually upgrade the software. You have to go in and actually download the file, upload it. I'm sure they'll improve that over time. The other thing that's a little bit frustrating is to do the minor incremental patches. You have to do them in the CLI. Again, I feel like that should be something that like in the sort of like modern like SaaS type application you can just do through the web portal. So yeah, so that's pretty much like the cluster upgrade completed. So we're getting ready to set up the backup, and we're going to show you a restore test. So what I've done is I've built a Ubuntu machine that we can basically back up and actually restore. We can show you just how fast it is. Now, we've done some testing and we know that even like 1 terabyte machines restore at the same speed pretty much as these sort of like 5, 10, 15 gig machines. So we'll walk you through the process in terms of how you can actually set up a backup. So the first thing you do, which we've done previously, is we've set up the sources. So we define the vCenter IP addresses, we've configured service accounts, and we're now going to protect a workload that runs on one of those sources. So we go up here to protect, click onto virtual machines, and we're going to choose to add objects. Okay, so we go through the wizard, we choose the source that we want to protect, and then we search in here for the machine that we want to protect. And we can see here there's one called backup test. Now, obviously, if you wanted to, you could select all the cluster or select different groups or select the data center as a whole, and then you can auto protect it with this sort of icon here that's the A. But for the purpose of this test, we're just going to select a single VM just to show you. Now, this VM is thin provisioned, but it has a 90 gig disk assigned. There's only going to be a few gig used. Just means that we can show you this demo. Keys to restore test policy. Our standard backup policy, choose our storage domain, choose more options. What we're going to do is we're just going to set a QoS policy, which backs it up automatically and chooses the right QoS policy based on the data. So that's just going to help us get the maximum throughput in terms of the actual backup job itself. Then there's various settings in here, so if we quickly run through what they are. So obviously we've defined the protection group. This isn't our normal naming convention, but again, it's just a test. We choose a storage domain. You can choose when you want the job to run, when you want the job to end. The QoS policy is to do with like how it assigns prioritization and across all the nodes and what throughput you'll get. We always set it to auto. We don't turn on these two settings to do with snapshots. We don't need any exclusions for this test. Again, because it's a test, we're not interested in app consistent backups. Indexing will allow you to index the VM job and actually restore files directly from the machine. Cloud migration, and we're not interested in that for this. Again, alerts. So you can configure email alerts for failure, success, etc. We define alerts for everything so that we always know if it's worked, no matter if it's a pass or fail. And then the SLA, this is quite useful. Basically tells you if your backup job ran within the time window specified. And that's useful to know because obviously if a job gets stuck, then it's going to fail its SLA, and that's a good way to know that you've got a job that's not working. And then you can set descriptions that's human readable, so you know what the job actually contains. So we'll click protect, and that will now go off and actually back that machine up. Now it is only a few gig, and this should only take a couple of minutes. Okay, so backup's finished. That was nice and quick. It only took 2 minutes and 32 seconds, which is what I'd expect. And probably a lot of that time is just sort of like background processing. So obviously the way that works is kind of, well, it's hidden away for you as easy, but it's a fairly typical backup job process. It's going to take a snapshot of the VM, it's going to do a hot of that disk, and it's going to lift that into a proxy. With this platform though, the proxies are all spun up on the actual platform itself, so you don't have to deploy any VMs onto your infrastructure to actually capture the data. So now we've got that backup, we can see it in here. We can see that it met the SLA, status is good. Now what we'll do is we'll go and do a restore. So if we flick over quickly to here, we can see that that VM is currently running. What I'm going to do for the purpose of this, I'm actually just going to shut that down. You can see we've got this window with Firefox open. And what I'll do is I'll just quickly shut that machine down or power it off. Just to show you how fast this restore process is. So we're going to go back to the Cohesity Helios platform. We're going to do a restore. So recovery, recover, virtual machine, VMs, search for the VM in here, this one here, recover options. We're going to recover it to its original location. We're going to choose instant recovery. which is literally pretty much instant. Existing VM handling, for the purpose of this test, I'm just going to overwrite the VM. You can, if you want to, obviously keep the existing VM and like rename it and stuff, but for the purpose of this, we'll just literally overwrite it. We'll set its power on, and we'll have it select the cluster interface itself, and we'll leave the network unattached. You can set whatever network you'd like it to be on, but this one, it doesn't have a network adapter attached at the moment. So click recover, and we will go and watch how fast this actually is. So that's started in the background. We'll flick over to here. You can see that it attempts to power off the machine. It's now been deleted, and it will now be connecting the platform in the background. You can see there, the VM just appeared, and that VM has now been restored. And now in a second, because we've set power on, we should see that machine actually power on. There you go, that machine's been powered on. So now if we connect into the web console, so what's actually happening here is it's actually mounted on the Cohesity platform itself. It's connected to this vCenter, and that machine is now actually in the process of booting up. So we go back to the Cohesity platform, we can monitor that restore. So we can see the instant recovery's succeeded, and currently it's migrating the data store. It's 29% complete. Now, of course, while it's doing that, that's going to affect the performance of the machine, but we should be able to get onto the console of that device. There we go. So the console of that machine is now active, that machine's powered on, and the restore is complete. So now that customer can get back up and running, albeit it is off slightly slower storage, perhaps than the customer might be used to, but these platforms are built on SSD, and that will perform relatively good, although at the moment, of course, because there's a vMotion running, that performance is impacted slightly. So in a second, we should go through right into the operating system. So that VM relocation is still running at the moment, 32% complete. Okay, there we go. So the backup test machine is now actually restored, and we can see just how easy it is to A, protect your workload, how simple that is to configure. You get a lot of flexibility in terms of configuration of that. And the restore, like that is the easiest restore next to probably volume level snapshots that we use on the NetApp platform that you could ever ask for. And that for us has just been absolutely fantastic, because we don't have to wait around now to restore stuff. Like with Veeam, we could do a restore test and we would be on like a big data set, like 20 terabytes. We could be waiting hours to days to restore that. Cohesity, we've done the same test since migrating that customer's data over, and we can actually restore that within a few minutes. So yeah, we've been super pleased, and yeah, we're looking forward to expanding what the platform does for us, rolling that into areas like Office 365, and yeah, maybe bringing out some self-service for our customers.